Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is beauty in everything. The problem difficulty is easy, and you need to know binary search as a prerequisite for this problem. Let's have a read at it. You are given a binary string b of length n, and it is called good if there exists any integer k that satisfies the following procedure. So we have this binary string b of length n, and it will be called good if there exists integer k that will satisfy the following properties. Let's see what is the property. The property is that k has to be greater than 1 and k has to be less than n. Now once we have this, k should divide n, and once we do this, we need to consider a binary grid of G that will be of dimension n divided by k multiplied by k. It means we will have k columns and k rows, right? Such that its major row order equals b. That is, for each value of I that will go from 1 to n divided by k, and where j will go from 1 to k, we must have g of ij to be equal to b of I minus 1 into k plus j. All in all, you just need to understand that since this n is going to be divisible by k, what we are going to do is we are going to like make these sections of length k so that we have k columns and k rows. Now, this is the operation that we're talking about with k. Now, a binary string b will be called beautiful if it contains a subsequence, right? Not necessarily contiguous, that is good. So, in our binary string b, if there exists any subsequence that can satisfy this condition, where we can choose a k whose length is greater than 1 but less than n, and with this k, we can construct a grid of k columns and k rows in such a manner that each row will contain at least one occurrence of 0 and one occurrence of 1. So if we can have this grid from the subsequence of b, the string b will be called good or beautiful. Now what we have is we are given a binary string a and we need to find the longest contiguous substring of a that is not beautiful, right? So for input format, we have t test cases, and for each test case, we will have two lines. The first line will contain the integer n and m, that is, the length of the binary string a, and the second line will have the binary string itself. Now for the output, we simply have to output the length of the longest contiguous substring that is not beautiful. As for the constraints, test cases will go from 1 to 10 raised to 5. Length of our binary string will go from 1 to 2 into 10 raised to 5. And since it's a binary string, it will only have the characters 0 and 1. Let's see some sample inputs. So for the first sample input, the length of our binary string is 2, and the binary string that we have is 0 and 1. Now if you remember the condition for k, it has to be greater than 1 and less than n. In this case, n is 2, and there is no number between 1 and 2. Therefore, the answer is 2, because this is not a beautiful string. As for the second sample input, the string that we have is 1001. Now, if we take the whole string, we have 10 and 01, and we need to find the whole length is k, right? So k has to be greater than 1 and less than 4. So the valid values of k that we can take is either 2 or 3. So let's try 2. So if we try 2, what can we get? We'll have 10 and 01. But hey, each row has at least 1 and at least one 0. So this is become beautiful. But we don't want this, right? So what can we do? 2 won't matter, 3 we cannot try because, well, 3 won't make a possible grid. So k will defeat. We are defeated here. We cannot check this. So let's increase our length. What if we try for 3? So if we have to try for 3, the substrings available to us are 100 and 001. Now again, the values of k that we can take from 1 and 4 is just 2. Sorry, 1 and 3 is just 2. And if you take k as 2, again, we cannot make a possible grid. Since we cannot make a possible grid, it is not beautiful. For that reason, the maximum length of substring that we can find where it is not beautiful is 3. Similarly, we can try for the last sample input. Let's see how we can approach the solution. So let's start from the bottom. As we know, the value of n can go from 1 to 2 into 10 raised to 5. So let's see, if you have a string of a single character, can you make a grid? Well, the answer is no, right? What if you have 2? Again, if you have 2, again you cannot make any kind of k, because now k has to be greater than 1, right? But k also has to be less than 2. There is no number in between. Same goes for 3. If you have length 3, k can only be 2. But for 2, you cannot make a grid. You cannot make a grid of 2 by 2 where we have 2 rows and 2 columns. So any length n that is less than or equal to 3, our answer can directly be n, right? Very easy. But what about 4? Let's say our n is equal to 4. Now in this case, what can happen? If we have a string of length 4, what are the possible values of k? Again, k has to be greater than 1 but less than 4. So 2 and 3 is possible. Again, 3 is not possible here because we cannot make a grid of 3 rows and 3 columns when we only have 4 elements. So 2 is the only valid case. So let's see, if we have 0, 0, what do we need below? We need 1, 1. This is a valid grid, 0, 0, 1, 1. What if we have 0, 1? In this case, below we would need 1, 0. So this is also a valid string. Again, let's try one more. If we have 1, 0 as first and second character, we would need 0 and 1. So this becomes 1, 0, 0, 1. And lastly, if we have 1, 1, this will become again 1, 1, 0, 0. So in all of these cases, if we have these 4 strings of length 4, if you're talking about it, they all make a valid grid. That is, they are beautiful, right? What other can you think of that will not make it beautiful? So one could be that if you have 1, 0, 1, 0, this is not beautiful. If you have 0, 1 and 0, 1, again, this is not beautiful, right? So this makes 1, 0, 1, 0 and this makes 0, 1, 0, 1. So when we are talking about 4, that is the smallest one, only these 4 are valid. These 4 are beautiful. So if we encounter these 2 of length 4, we can say that these are not beautiful and our answer would be 4. Now, why are we going through all this ordeal? Let's see. Now what happens if your n is greater than 5? Now remember our task. What we have to do is we have to choose a substring. That is, we have to choose a contiguous substring, right? Once we have chosen these substrings, what we can do? We can choose any kind of subsequence, right? This is the criteria. We can choose any subsequence. That is the reason that we are learning about n is equal to 4, because this is the smallest grid that you can ever make, because your k has to be greater than 1. What is the next number and the smallest number after 1? It is 2. So you can make a grid of 2. This is the smallest possible. So whenever we are trying to find a substring, our main challenge will be that when we are finding a subsequence, we will find this 4 one. If we find a 4 one and we can make beautiful, the whole substring can be called a beautiful string and our purpose would be defeated, because if you remember our goal, we need to find a string that is not beautiful, right? So we are eliminating the strings that might end up as beautiful. So for that, what we are going to do is, as we can see, for each column to have at least 1 1 and at least 1 0, we need to have at least 2 zeros and 2 ones, as it can be seen, right, in the smallest 2 by 2 grid. Only this sequence of 1 0 and 0 1 0 1 do we defeat this. But now you might have a question. Why is it that for 4 we can do this, but in 5 is it guaranteed that everything will be beautiful? Well, let's check. So you obviously have seen this, right? If you have 2 times 0 and 2 times 1 spread out in a substring, we can always form these and get our answer. But now you question, Mother, what about these cases? So let's see what would happen if the length is 5. Let's start with 1 0 1 0. You can either have a 0 at the end, right? Or let's say you can either have a 1 at the end. Now in this case, again, what you can do is you can simply choose 1 1 and 0 0, right? 1 1 0 0. It is a valid answer. Yes, it's a valid answer. Now your whole string can be called beautiful. There's nothing you could do. What about in this case? Again, you can choose 1 0 0 1. Is it there? Yes, 1 0 and 0 1 is there. Again, your whole string of length 5 now just became beautiful. So we know that for n is equal to 5, if you have a pair of 0 and 1 in a substring, it will always be beautiful, right? So what we need to find is, we need to find a substring in such a way that it has either 0 to be at most 1 times, or it has 1 present at most 1 times. If this is the case, even if you try to find the smallest 2 by 2 grid, it will be impossible. You cannot find it, right? Because for each column to have at least 1 0 or at least 1 1, you need to have at least 2 0 or 2 1. So what we are going to do is, we are going to traverse using binary search. So using binary search, we know that the minimum is 4 and the maximum is n. So in between, we'll find a middle term and we'll do a sliding window. That is, we'll make a window of size this, mid. In this, we'll find what is the frequency of zeros and 1. If we satisfy this position, that either the count of 0 is less than equal to 1, or the count of 1 is less than equal to 1, it would mean that this is a valid substring. This substring cannot make a beautiful string, right? So this will be a valid answer. Mid will be a valid answer. If this becomes a valid answer, we'll try to search now in this range. Again, this is binary search. If mid is not a valid answer, we'll search in the lower ranges. With this, we'll find what is the maximum value of mid for which there exists the count of 0 that is less than equal to 1, or count of 1 that is less than equal to 1. If you find this substring will be a string that is not beautiful. It would mean that you cannot find any subsequence that will give you a beautiful grid. Now there's just one exception, that is our n equal to 4. If n is equal to 4, we will need to find 1 0 or 1 0 1 0 or 0 1 0 1. These two substrings. If you find these two substrings, it would mean that we cannot form a beautiful string. If other than this, if anything else is present, it will always form a beautiful array. So this is the gist of the approach. We'll do a binary search, and for that size, we'll run a sliding window. In the sliding window, we'll keep count of the frequency of zeros and 1. If any of them, either of them, has a frequency of less than equal to 1, that is a valid size. It means that for that size of substring, we have a string that is not beautiful. We'll do this binary search and find the maximum length for which we can find a substring A that is not beautiful. And this will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and then our string s. Now, as you know, the minimum answer can either be less than equal to 3, because anything that is less than equal to 3, it will be not beautiful string. So once we have this, what we are going to do is we are going to start our binary search that will be between the length of 4 and n. We find a mid length. For this mid length, we are going to run the sliding window. For that, we have written a check function. In the check function, we pass the string and our window size. Once we have this window size, we are going to traverse over this window size and keep frequency count of element 0 and 1. Now, if either of the element has a frequency of less than equal to 1, it means that this length of substring can be found that is not beautiful and is a valid answer. Now in case our k is equal to 4, as we have seen our approach, we need to find if the sub, that is the substring of length 4, is equal to 1010 or 0101. If that is the case, this length 4 is also a valid solution. Now we do this by moving the sliding window till end of our string. So till the end, we try to find whether there exists a substring that is not beautiful. Now this check is a boolean function. This will return either true or false. Now if the mid that we have found is a correct answer, it would mean that now we need to search ahead. So we try to find the maximum value of this window size. Once we have found this, at the end we print it, and as we can see, we have got an EC in our C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and our string s. Once we have this, we initialize the limits of our binary search. Lower limit will be 4 and the upper limit is n. We initialize our answer as minimum of n comma 3 because anything less than equal to 3 will never be a beautiful string. Now for our binary search, what we do is we define mid as the window size. For this window size, we traverse over string s and check whether there exists a substring of our window size that is not beautiful. To check whether it's beautiful or not, we find the frequency of zeros and 1. If either of them has a frequency of less than equal to 1, it means that this substring window is not beautiful and is a valid answer. While doing so, in binary search we find the maximum length of this substring and we print it at the end, while taking care of the special window size of 4. At the end, when we have the maximum size, we print it, and as you can see, I've got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.